In question number 53, f and g are two twice differentiable functions and the value at -1, 0 and 2 are given. In every option we can see we have to talk about f dash minus 3 times g dash x. So we can assume a function capital Fx as fx minus 3 times gx. And if we are evaluating the value of the function as at f of -1, f of 0 and f of 2, and we can see this is going to be 3 minus 3 times 0, that is 3, 6 minus 3 times 1, that is 3, and this is 0 minus 3 times this, so this is going to be 3 again. So the values at -1, 0 and 2 are same. We can see according to Rolle's theorem, the value of capital F dash x is 0 in this interval and in this interval, but this will give us at least. But in the options it has been asked exactly. For that we have an extra information that f minus 3g का double derivative is never 0 for x belonging to -1 is 0 union 0 to 2. So it is not speaking at x equal to 0, but the function is twice differentiable. So we can see f double dash 0 must exist, but in these intervals the function cannot be 0. So if we are sketching the approximate graph of capital Fx, we will have to keep in mind two things. One is the values at -1, 0 and 2 are same, and the double derivative will not vanish in this interval and this interval. So in this interval -1 to 0, the function will be either concave up or concave down, which has the possibility like this. Similarly, in this interval, this can be concave up or concave down, and which will have this possibility. Or alter possibility can be like this. This can be like this, concave down and then is concave up. In both the cases, we can see there is exactly one x in this interval where f dash x vanishes, capital F dash x vanishes, and in this case 0 to 2. Similarly here also. So we can see the function fx minus 3, f dash x minus 3 g dash x will vanish exactly one times in -1 says 0 and 0 say 2, and hence the correct answers for this question will be B and C. In question number 54, fx is given to be 7 tan raised to the power 8x and so on, and x is between -pi/2 say pi/2. We have to comment upon which option is correct. In option A, it is given 0 to pi/4 x fx dx. So this can be written as x fx. In fx, we can see if we will take 7 tan ki power 6x common, we are left with 1 plus tan square x, that is going to be sec square x. Similarly, if we are taking -3 tan square x common, we are again left with sec square x. So sec square x will be common. Now we can see we can use integration by parts. For this purpose, we can integrate this easily. So we are assuming this is second function and this is first. If we are using integration by parts, this is going to be first function as it is integral of this. And if we are assuming tan x is t, so this is going to be t raised to the power 7 upon 7. So 7 will cancel out and this will be tan raised to the power 7x. Similarly, this is going to be tan cube x from 0 to pi/4. Again, we can see this is going to be minus 0 to pi/4. And by differentiating this, we will get 1, and this is going to be 10 raised to the power 7x minus tan cube x dx. Now it is easy to see if we will put pi/4, this is going to be 1 minus 1, that is 0, and again at 0 this is going to be 0. So this part will vanish, and this is going to be minus of 0 to pi/4. And if we will take this minus sign inside, this is going to be tan cube x minus tan raised to the power 7x. So this is going to be tan cube x into 1 minus tan raised to the power 4x, which can be written as 1 minus tan square x into 1 plus tan square x, that is sec square x. And if we will put tan x equals t, so this is going to be tan raised to the power 4x upon 4 and minus this is going to be tan raised to the power 6x upon 6 from 0 to pi/4. So this is going to be 1/4 minus 1/6. We can see LCM is 12, and this is going to be 3 minus 2, that is 1, which is correct in A option. So A option will be correct. Now it is also asked 0 to pi/4 fx dx in option B and D. So this is going to be 0 to pi by 4 7 tan raised to the power 6x fx minus 3 tan square x sec square x dx. And again we can see this is going to be tan raised to the power 7x integration minus tan cube x from 0 to pi by 4. If we will put pi by 4, this is going to be 1 minus 1 0, and again at 0 this is going to be 0. So this is option B, and hence we can see the correct answer for this question is A and B.